So I'm Pramukh, I'm Ravi Podar, I'm one of the semiconductor folks at AWS. And today we're going to talk about true hybrid SaaS cloud architectures for EDA workloads. So what is really important in chip design? It's time to market is one of the biggest things, because as we all know, if you're late to market, you can lose millions, tens of millions, hundreds of millions, even billions of dollars in lost revenue if you lose a socket, right? So if you look at the actual design flow, like standard design flow, you have architecture, hardware, software, pre-silicon validation, QA testing, and they all are their own peaks, and they're all kind of spread apart because there is somewhat of a serialization in that process. Ideally, what you want to do is you want to put these peaks together, do as much work in parallel, and shorten your tape-out window, right? And and a couple of really good use cases for this are FPGA prototyping and emulation and verification. And there's just a lot of steps. Now the question is, in either one of those, can you move these things together or move them much closer together so as to speed up your tape-out window? And one of the big constraints you have is computation ability and storage ability. And when you're on-prem, generally, you have a certain amount of compute, and you often run out of that compute, right? And if you look at what compute looks like at big chip companies today, you're probably ordering on hundreds of thousands of cores per customer, per company. Some of them are in the millions. Intel, I think the last publication they had between 3 to 4 million cores on-prem for chip development. And so, but that's still not enough, right, as your chips get more complex, right? So what are the major challenges? I think we talked about them a little bit in the intro, but the first one is increasing chip size and complexity, right? So 91% of executives are pushing for a chip or a chiplet in 2 years, yet only 9% are confident that they're actually going to make their schedule, right? If you look at some of the most recent announcements from some of the biggest chip companies out there, like NVIDIA, they have basically said they're going to go to almost a 12-month release cycle. For chips in the billion transistor range, that's absolutely astounding. But the only way they can get there is extreme efficiency and availability of huge compute, like what they do on AWS. Product verification is key, right? Because you have to be confident that what you designed is what you thought you designed, right? So there are actually way more resources put on verification of a design than actually designing the chip itself. And this complexity is just exploding, right? As your chips get bigger, as you go to smaller process nodes, there's more and more things you need to test. And of course, we're not giving you more money to do these chips, so 70% of companies risk losing first to market edge because, long design cycles and not much increase in budget or schedule. So cloud, why cloud, right? So one of the big reasons cloud is so advantageous for chip design is because, number one, you get access to the latest compute, right? If you look at an on-prem data center, if you're sitting on, say, 50,000 cores or 100,000 cores, you would want to upgrade those compute nodes to the latest compute as soon as they come out, but it's not really practical or feasible, right? And so if we look at, a company based on a lot of market research, which we have done with our customers, most customers do a refresh of about 20 to 25% of their compute on a year-to-year basis. That means if you take a snapshot of your data center, you have something like this, right? A 25% distribution of different core generations in your compute cycle. And based on data we have from Intel, that means your data center is only running at about 77% of the performance as compared to if they were running all the latest EDA or latest compute cycles. And this has a direct impact on your EDA tool licensing. EDA tool licensing is extremely expensive for those of you who know, and often it can be 5 to 10x your annual IT spend. And so if you look at that, $20 million on annual spend on EDA licenses is actually on the low side for a small to medium company. But that means because of slow compute, you're losing $4.5 million worth of efficiency out of the bat. Right, so if you can go to the cloud, run all latest compute, you're going to get that money back instantly just on EDA license ROI. So what is a true hybrid workflow? Right, so the idea is that you have on-premises, but you can offload to the cloud, right? Or you could run entire parts of the workflow in the cloud. So for example, in this case, you could run this entire workload in the cloud, but then just come back on-prem for, say, silicon validation or FPGA prototyping and stuff like that. Similarly for emulation, right? All big chips have to go run through emulation, right? Hardware emulation. But that involves a lot of simulation, build, and then actual emulation. So you can actually move a lot of this part to the cloud as well, right? And then you're able to compress your design cycles. You can run hundreds of thousands or millions of simulations in the cloud. Some of our customers, like ARM, are running close to 400,000 cores in the cloud today in AWS, just to simulate the chips, just to verify them. Some of you may not know, right, is semiconductor design actually supported in the cloud, right? If you look at the standard chip design flow where you have front end, back end, and production and test, every one of these things is fully functional from all the major vendors in AWS today. And customers are doing full RTL to GDS2, or they're doing heavy back end 3 nanometer design. Amazon themselves is a silicon company, right? They make a lot of their own silicon at very advanced technology nodes. And all of this is fully functional in AWS today at very high performance and low cost. With that, I'm going to hand it off to Nupur for the next part of this presentation.
Thank you, Ravi. Also, thanks for sharing the small examples, especially in terms of metrics on what the current trends are and where cloud is going to help in that. So I'd like to focus a little bit on the requirements and what we are proposing here today in terms of meeting those requirements. From a hybrid or a true hybrid, some on-premise part, some on-cloud part of your design. So one of the things that we are seeing a lot more from our customers being requested is a high disk space optimization in cloud. So even though you pay per use, you still have to pay on cloud. It's not like it's free. So how best can you optimize that? And some of that is also in terms of transitioning your data from on-premise to cloud. So it's also the migration effort, estimating that, and then estimating the costs for that. So how best can you optimize that? Another thing is if some of that data is no longer in use, or maybe you're running multiple simulation runs throughout. Some of the old simulation logs are no longer required. You just can go ahead with the test benches and keep those in. But some of those unused data, how effectively can you scrub it off or clear that and make that storage available for the next simulations in line? And the last one that I like to have here is, I don't want to just lift the entire thing and put it on cloud. I don't want to have all of my data on cloud if I'm just running simulations on cloud, if that's my use case. I want data that's relevant to my simulations only on cloud. I want the rest of the design to stay on-prem. Or the other way around, if I have that, if I have my design on cloud, I don't want the entire design to have to be downloaded on-premise and use up that storage. So some of the things that we are proposing here is to have more of a design-aware data management. So your data management system, the way you are moving data or the way you're handling data, is more aware of what your design actually is. So you'll only pull the relevant data either from on-premise to cloud or from cloud to on-premise. So wherever you're running your simulation, you'll pull up only the simulation-related data that is needed. The next one is that you would be able to keep track of file revisions. So maybe I tag certain revision that says simulation ready, and only that revision goes on to cloud. The rest of the data still stays on premise, and my simulation ready, let's say a cell view that's simulation ready, is available on cloud. So that becomes a very good way for me to classify what needs to be there on cloud. And last but not the least, I could also, let's say revision 4 on cloud is simulated. It passes my simulation. I'm satisfied with that. I find a way that this is tagged now golden. These are my golden results, test results. And after that, some design progress, the design progresses on premise or on cloud. And then I want that golden simulation to be run again. So what happens to those previous revisions in there? So you have the ability to scrub those unused revisions from cloud, so that next when you bring your design back on cloud for the next simulation run, it's the new revision that comes back in. So a couple of things we are presenting here today. something that we have deployed at our customer end as well. And we are seeing more and more of these requests, especially in terms of bursting to cloud. And now that that's been proven and used also with existing customer infrastructure on premise, some of those things have ironed out as well. So that's why we thought of putting it as proven architecture, since we have customers along with AWS and Keysight who run their designs on cloud. So one of the things that we are suggesting here is that your repository, which is the final source of your information. So you're committing your data to a repository, which is your data vault. That goes on cloud. You could have still have your on-premise infrastructure and have a cached version of your repository that goes on-premise. So this is your on-premise data center. As a user, you could then log in with your VPN session as you're used to and get access to your EDA workflows, whatever tools that you're using for design or simulation, such as Keysight ADS. If you're using for simulation, you could go via that. And you could also have virtual desktop access out to the AWS environment and still have access to your data on cloud. So your final data point then rests in cloud. The most typical use case for that we have been requested from our customers that we've seen is that the cloud is your primary design environment. So as designers, they will get access to their AWS virtual desktops and then access their data. Yet, for the emulation aspect that we saw in that example earlier, or the FPGA prototyping aspect, they can still come back to the on-premise to then conduct those things. You know, I have my FPGA board in a lab in my organization. I get that data back on. I see my bulbs glow. I'm good. The second one is if I flip that. So if I have my final data vault that goes on-premise, and I use the AWS cloud for my bursting. So that becomes the simulation use case. So where my designers primarily go to on-premise data center, they will check in, check out, they will do their design process on-premise. But they will burst to cloud for peak simulations. So that's where they can use the cloud leverage in terms of expanding the resources that are needed for the simulation. So even if you run out of, like Ravi mentioned, run out of the cores on-premise, you have the ability to have on-demand cloud burst resources available. The typical use case is when most of your designers are on-premise or your design teams are located at one geographical location or a couple of geographical locations that then collaborate with each other. So just to summarize, it's not necessary to have it all on-premise, all on cloud. You have the ability to pick and choose. It need not even be split 50-50. 50% of my design has to be here on-premise and 50% on cloud. You could just pick and choose what you want to put on cloud and what you want to put on-premise. And that flexibility is something that a design data management tool can give you, since that works across the entire design flow, right from your requirements to your design to your tape outs, all the way up to test and measurement. So I'd like to check that you have the design-aware data management. So you bring only the relevant design data out there. You have multi-vendor EDA workflow support. Like we mentioned in our intro, Scott and Catherine mentioned in the intro, where you have multi-vendor EDA workflows. So now it's more and more a need that you have those interoperable flows that are supported, not just on-premise, but also on cloud. And your user, your end designer, is able to seamlessly move between the two. Because especially from point of view of licenses, checking those out as well. Because you are using cloud or you're expanding onto cloud to get that benefit, you don't want the process to be slowed down for your users. So have that seamless way to support multi-vendor EDA workloads. And lastly, have that what we call as a true hybrid, one that really fits your use case, where what part of the design you want to go on cloud and what part you want to stay on-prem. So we support both on-prem deployments, on-cloud deployments, and a good combination, a healthy combination of a true hybrid workload. So that's about it for today.